Hello everyone and welcome back. This is Mr. Keeney and we are on our last section of notes in Unit 2, which is section 2.7. And today we'll be talking about a little bit of angle pair relationships and dealing with how to prove things about these angles here. So when we look at these angles and these angle pairs, it's important that we remember that our fundamentals, that vertical angles are congruent, that linear pairs are supplementary, that we're going to be taking a look at right angles here. I almost gave away a spoiler, which, you know what, I can get into it right now. Right angle congruence theorem, which basically says all right angles are congruent. So there's not much to really spoil there, but every right angle ever is going to be 90 degrees. So for that case, we can say that all right angles are congruent because, like I said, all of them will always have the same measure. So we can use these to prove certain things. And for example here, example 1, it gives us some perpendicular lines, which we'll have to talk about perpendicular and what that means. Down here you can see we're using the definition of it. And then we're able to prove things about angles. So the first thing we do is just bring in a given information, which says that if we look at this picture here, JK is perpendicular to KL, and we can see it's marked with this marking here, which we're about to talk about. And that ML is perpendicular to KL, which is also marked right here on our picture. And when we have perpendicular lines, what that tells us is that they intersect to form right angles. So angle K and angle L are right angles. That is what it means to be perpendicular, intersect to form right angles. So that is where we're getting the definition of perpendicular lines. And we just talked about in this congruence theorem here that I am now ready to say that angle K is congruent to angle L because we just talked about that right angles are congruent. So the right angle congruence theorem tells us these two angles must be congruent. So right angle congruence theorem, there's just an example of its use. And there's other theorems about angle pairs and angle pair relationship, the first one being congruent supplements theorem. It says if two angles are supplementary to the same angle, then they are congruent. And let's take a look at an example here. It says if angle 1 and 2 are supplementary and angle 3 and 2 are supplementary. So notice that 1 is supplementary to 2 and 3 is supplementary to 2. Then what we can say is that, oops, did not mean to do that, angle 1 is congruent to angle 2. And really the reason is if we were to talk about what it means to be supplementary, it means that if I were to take 1 plus 2, that would have to be 180. Well, for the same reason, the measure of angle 3 plus measure of angle 2 equals 180. So I know it right here it says if you want to see the proof, go to this page, but I'm going to go ahead and continue it out real quick. Through substitution, I can just say, well, these two are going to be equal to each other. The measure of angle 1 plus the measure of angle 2 has to be equal to the measure of angle 3 plus the measure of angle 2. I've taken both of these and set them equal to each other. And then I'm just going to take away the measure of angle 2 from both sides, and we get that the measure of angle 1 is equal to the measure of angle 3, and if their measures are equal, then they would have to be congruent. Now, do you need to know this proof and be able to reproduce it? No, but you will need to know that the congruent supplements theorem, that if two angles are supplementary to the same angle, then they are congruent. And for the same reason, we have the congruent complements theorem, which is the same thing, except for we are going to be talking about complementary angles. And the difference between complementary is that they will add up to equal 90 degrees instead of 180. So again, if we were to look at angle 4 and angle 6, we are seeing that they're both complementary to angle 5. Then we know that angle 4 would be congruent to angle 5. And I guess I could use a diagram to explain that later, but either way. The last one here, or not last one, the second to last one, linear pair postulate. If two angles form a linear pair, then they are supplementary. It looks like our picture got mixed up here, but here's a linear pair, and we know that if they form a straight angle, that I would add them together to get 180 degrees, because that is the measure of a straight angle. And the last one here, vertical angles. Vertical angles are congruent. So looking here, angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Maybe I can write that out. Angle 1 congruent to angle 3, angle 2 congruent to angle 4. All right, and then we are going to go ahead and use these, and we got a proof and then a couple examples below. We are going to talk about angle 4 being a right angle and somehow use that in the picture to get that 2 and 4 are supplementary. So the first thing we do is just bring in our given, which is that angle 4 is a right angle. And they want me to talk about the definition of a right angle. Well, the definition of a right angle is that the measure of angle 4, that right angle, is equal to 90 degrees. Then it brings out something kind of what feels out of nowhere, which is angle 2 is congruent to angle 4, but let's take a look at the picture here, and it makes sense because these are vertical angles that we just talked about. So this would just be, okay, they're vertical angles. And then if they are congruent angles, that means they must be equal. So the measure of angle 2 equals the measure of angle 4. We're just saying that if they are congruent, they are also equal. That is what the definition of congruent angle says. And then I am going to say, well, the measure of angle 4, that's nice, but don't I know something? Don't I know that it's 90 degrees? So I'm going to substitute it in. Substitution. Measure of angle 2 equals 90, which now we're getting something somewhere here because I'm going to take, here's kind of the magic step. The measure of angle 2, I'm going to add something to this side. I'm going to add 90 to this side. And on the right side, I'm also going to add 90. Oops, I didn't mean to do that, because 90 plus 90 is 180. And now remember, everybody, that 90 degrees is the same as the measure of angle 4. So we have the measure of angle 2 plus the measure of angle 4 equals 180, which is another substitution. Oh, I did not spell that right. Let me start that over. Substitution. There we go. And then I'm actually going to need an 8th step here, because now that I know they add up to equal 180, I can bring in and say angle 2 and angle 4 are supplementary. And that is the definition of supplementary angles. So another little proof. By this time, hopefully we've done some practice in class with 2.6, so this is going a little bit better this time, but still we're going to continue to work on these proofs, so please let me know if you have any questions. But let's get to the more algebraic questions here. We have 3 and 4. Oh, and that's it. I thought we had 5. So the example 3 here says that the measure of angle 2 is 63 when we find the other ones. Well, here is 63 up here. And now vertical angles say that these would be equal. So the measure of angle 4 is 63 degrees. That's not too bad. And that we also know that 1 and 3 are going to be the same. But not only that, they're going to be linear pairs with the other. So I just need to do 180 minus 63. And I see I get 117. So to make this a little bit clearer here, the measure of angle 1 equals 117. And it's going to be the same as the measure of angle 3, which is 117. And the first one we did was the measure of angle 4, which was 63 degrees. So using what we knew about vertical angles and supplementary, or linear pair, I should say. And now here we need to write and solve an equation and then find x and use it to find this angle right here. So I see these two are a linear pair. In a linear pair, they're supplementary. So 4x minus 1 plus 113 would be equal to 180. So there is my writing the equation. Let's try to solve it now. I got like terms. I got 4x plus 112 equals 180. I'm going to take away 112 from both sides. These cancel out. I got 4x equals, what would that be here? 68, I believe. And then we're going to divide by 4. I'm going to grab my calculator and make sure I don't make any silly mistakes. 68 divided by 4 is 17, so I get x equals 17. So now we have found x, and we're going to use x to solve. So the measure of angle FKG, which if I were to look at what that is, FKG is 4x minus 1. So instead of x, though, I know x is 17 minus 1. So let's substitute that in, and we're going to solve. So 4 times 17 is 68 minus 1, which is 67 degrees So here is kind of that final answer. So using these angle pairs in a variety of ways, using it to prove things, to find things. But yeah, so please, again, let me know if you have any questions. We'll continue to do work in class on these. So yes, just let me know. I will talk to you guys